Okay, so here we are at part 5. Can you believe that? We're going to try to do 5 or 6 more problems in this video. And so we're just going to start off with 17. We're about to test a hypothesis using data from a well-designed study. So obviously this is meeting our assumptions, which is really important, which is true. A large p-value would be strong evidence against the null hypothesis. Okay, that's false. Alright, you want a really small p-value to have strong evidence against the null hypothesis. We can set a higher standard of proof by choosing alpha at 10 instead of 5%. That is also false. That's a lower standard. It's actually easier to meet the 10% than it is to meet the 5%. If we reduce the risk of committing a type 1 error, then the risk of a type 2 error will also decrease. There's an inverse relationship here. Alright, now I know we haven't mentioned this really in class, but as type 1 errors increase, then type 2 errors decrease. There's just an inverse relationship there. Okay, we're going to talk about that more in chapter 21 and what those mean, but this is the basic concept that you need for this particular problem. So this is going to be a none. Okay. As you can see, I've already crossed out 18. This is a little bit deeper problem with the type 1 and type 2 errors, and so we're not going to use this. We're going to save this for chapter 21. I don't know how this little problem snuck in there, but we're not going to worry about it. So that brings us to 19. To plan the course offerings for the next year, a university department dean needs to estimate the impact of No Child Left Behind legislation might have on teacher credentialing program. Okay, historically, 40% of the university's pre-service teachers have qualified for paid internships. So your P here is going to be 0.4. The population is those pre-service teachers, and the characteristic is qualified for paid internships. The dean looks at a random sample of internship applications to see what proportion indicate that the applicant has achieved the content mastery that is required. Alright, so we're starting to meet assumptions as we do a random sample that's probably independent, and so hopefully we have the correct sample size, right? So based on these data, he creates a 90% confidence interval. So here's the interval, right, from 33 to 41. This means that our P should be in there, and look, it is. P is in that value. Could this confidence interval be used to test the hypothesis H0 is equal to P40? That's right, this means no change. Okay, so that's good. And P is less than 40. This is good because there's my less than for change at the 5% significance level. Alright, well, we already have a 90% confidence, so that's okay. Because it's one tail, you're going to use 5%. One tail is half the alpha for confidence. Man, my writing is terrible. Here, let me rewrite this. Okay. It's still the same stuff, but I want to make sure that it's clear, right? One tail, right? And this is one tail. The less than is making it one tail. Makes alpha half the normal for a confidence interval. Okay, so this is fine. This is good. This makes us happy right here. Okay, not a problem. And so now, as I look at A, obviously yes, okay, because we've met all the criteria. Since 40% is in the confidence interval, he fails to reject the null hypothesis. All right, so we do want to fail to reject because 40 is in the confidence interval. So this one's making me the most happy. Yes, since 40% is not the center of the confidence interval, he rejects it. It has nothing to do with being in the center. Don't have to be the center, just have to be in there. No. Okay, no. No, because the dean only reviewed a sample. No, it's not no, it's yes. Okay. Yes, since 40% is in the confidence interval, he accepts. Oh, accepts, not squishy enough. Okay. So the answer here is A. All right. We always use the terminology fails to reject, and we only care that it is in the interval, not in the center. All right. Okay, so for 20, obviously, this is again one of those type 1, type 2 error things that we're going to talk about in chapter 21, so just skip it. Alright, so 21. We test the hypothesis P is equal to 35 versus P is less than 35. We don't know it, but actually P is equal to 26%. With which sample size and significance level will our test have the greatest power? Okay, so alpha and power also have an inverse relationship. As alpha gets greater, the power of the test goes down. Okay, so but we haven't talked about how to deal with this particular problem, so I'm going to skip this one. Alright? Of course, I think this makes us happy because we had enough stuff to study and people are freaked out probably. Alright? Oops. Too far. Okay. So, a statistics professor wants to see if more than 80% of our students enjoyed taking a class, right? So, the more than is going to be really important. The 80% is going to be our P, right? So P is going to be equal to 0.80 P naught, and then our P alternative is going to be more than 0.80. Okay, so this is going to be our null hypothesis. This is going to be our alternative hypothesis. It looks like 22 is fitting A very nicely. Remember, for the null, you don't want greater than or less than stuff. You certainly want equal to. So I've gotten rid of all but this one. And then, of course, for D, this is less than. And so less than makes me sad. So we're going to go with A here. All right. Wow, we really cranked through a lot today. All right, with this particular video. So obviously for 24 is a type 1, type 2 errors. So we're going to get rid of that one. So we'll finish up this video with 23. Suppose that a manufacturer is testing one of his machines to make sure that the machine is producing more than 97% good parts. Alright, so they give us the hypothesis there. The test results in a p-value of 0.122. Alright, so this is really important. My p-value is 0.122. Unknown to the manufacturer, the machine is actually producing 99% good parts. Okay. What is the what probability happens as a result of the testing? Okay, look. The question that you want to be concerned about is if the p-value is greater than alpha, then we fail to reject. And so we're going to believe the machine is producing 97% good parts. Okay? Again, the type 1, type 2 errors are so we're going to be looking at fail to reject, right? And fail to reject. Okay? And it turns out that if it's actually higher, we've made a type 2 error. And so the answer here is B. but don't worry about this one. Alright, hold on. Here, let me change color. Don't worry. Alright, no type 1 or 2 errors on exam. Alright, so that gets us to question number 25 for our next video, and this is where we're going to start off with. Alright, thanks a lot.